Hello my dears. A very good morning to all. How are you all? I hope you are all fine. Okay. And all are studying, right? All are studying. I hope so. All are revising. It's really good. And in the last session we discussed something about Laplace transform. Okay. So for electrical view, the Laplace is actually, I did some problem now, so that's enough. Okay, and you have to do more problem if you get from somewhere else. Okay, you have to do that, and we will do when question paper solving after end of the session. We will do the question paper solving. So at that time also we will do some problem regarding the Laplace transform, but you have to practice. Okay, your own level. So next session we are going to deal with these filters. It is actually electronics related, no? If you are preparing for something related to electronics, no? Electronics or electronics and communication, then it will be more and more important, because filters, design of filters, no, problems regarding filters will become. But as far as our concern, our electrical concern, no, filters, actually we don't need to go deeper. We don't need to go deep to this topic filters. We just need an overview. Okay, what are the different types of filters? What are the peculiarity of such filters? How can we find whether the given filter is a low pass filter or high pass filter or something like that? Okay, we will discuss that. And filters are nothing but, it is used to filter out certain frequencies, right? Filter out something means filter out certain frequencies. In electrical, it is filter out certain frequencies, which means in many applications, no, many applications, there is a requirement of what? Filtering out or stop some frequency or up to some frequency, and you have to pass a certain frequency after that, or we have to pass certain frequency and we have to stop certain frequency after that, and we have to pass a particular frequency, and beyond both ends of the frequency we should eliminate. So that are the situations where we really need filters. Or filtering means, it's a physical meaning of filter means nothing but sorting out. Now more clarity will come, right? When filtering, more clarity or more precise output will come. So in the same manner, filter also do the same thing. It filter out the unwanted signal from the original signal, and we get a pure output or the expected output. That is the meaning of filters, right? That is the meaning of filter. So there are so many type of filters. First we have to see low pass filter. Low pass filter. So the meaning of low pass filter is that if you plot a graph between frequency and gain, low pass means it only pass the low frequency and stop the other frequency. So the PB means pass band. So it will allow certain frequency, and whenever the frequency is increasing, it will stop that frequency. So this is pass band and this is stop band. That is the meaning of a low pass filter. So it is only allow low frequency signal to pass, and after that it will block the remaining frequency. That means the higher frequency it will block. That is the meaning of low pass filter. Low pass filter. It will allow only low frequency signals. And next is high pass filter. High pass filter, or this is LPF and this is HPF. Okay, high pass filter. So if you draw the graph of that high pass filter, frequency versus, this will be the graph, and this is nothing but the gain. So if you draw a graph between this gain and frequency, you will obtain a graph like this. That means up to certain frequency, that means the lower frequency, it will block, that filter will block, and after that the filter start what? Passing the remaining frequency or the higher frequency. So that is the meaning of high pass filter. It pass only the high frequency signal. And next is band pass filter. The graph of that filter is like this, similar to this. Band pass means it allow particular band of frequency, and the remaining will be the stop band. That means This will be the gain of the, gain versus frequency graph. That means it allow particular band, or particular band means particular width of frequency, and remaining all the frequency, whether it is low or whether after that high value, it will be blocked. That is the meaning of what? Band pass filter. And next one is band stop filter, or BSF, band stop filter, and this is band pass filter, BPF. Band stop filter means this will be the graph, frequency versus gain graph. Band stop means it particular band will be stopped and the remaining will be pass band, or the remaining frequency will be passed. That means a certain range of frequency will be blocked and a certain band of frequency is passed, stopped, and again a certain frequency will be again passed. That means a band stop filter. That means a portion of the frequency or a band of frequency is stopped here. That is the meaning of band stop filter. Okay, and all pass filters also there. All pass filters also there. All pass filter, if you draw the graph of that gain against bandwidth or frequency, it will pass all the frequency, or pass band will be all the frequency, it will be pass. So these are the but simple graph showing the different types of frequency, filters, and let's discuss in detail one by one. Okay. First we have to see first order low pass filter. First we have to see first order low pass filter. First order low pass filter. First order low pass filter. See, so a first order low pass filter, this is the diagram of a simple first order low pass filter. An RC circuit, C is parallel with respect to the input side. So what will be the Laplace equivalent of this circuit diagram? What will be the Laplace equivalent of this circuit diagram? It is VA of S, this is R, 1 by CS, right? 1 by CS, and this is nothing but V0 of S, right? V0 of S. I want to ask you a certain question. Why this R is keep as R in Laplace transform also? What is the reason? This is my question. You see R now, here it is R and here also it is R. That means while transferring a time domain R to a frequency domain or a S domain R, we don't want to change that R. That means the Laplace transform of R is simply R itself. Why it won't change? Why it won't change? That is my question. What is the answer? What is the answer? See, this R is, how can we define that R first? How can we define that R first? According to Ohm's law, V of t will be equal to I of t into R. Real? Is it correct? Or R will be equal to V of t divided by I of t. Or if you transform the same into what? Laplace transform, it is nothing but V of S by I of S. Bus. There is no changing R here because R is a linear element and its value it is not depend upon time. Its value may depend upon the temperature, but its value not depend upon time. Only if something is time variant, then only we can have a Laplace transform. Then only we can have a Laplace transform. Then only we can have a Laplace. Even though the supply is DC or AC, DC or AC, it's time varying, it's time varying. That's why its value will be V of t by S. The constant value is nothing but V of S divided by, or V of t divided by F. If it is a constant value, DC value. If it's varying means simply V of S only. If it's a constant value, it is simply what? V of S by S. If it's constant means V of S by, but it is an AC, it is an AC, it is varying, right? So simply it is Vi of S by S. Suppose it is DC means it is Vi of S by S will be here the answer, right? That is the difference. So anything a constant can be converted to what? Converted into time, Laplace transform as Vi by S. But a resistor, in the case of resistor, R equal to V of t divided by IFI, or R will be linear element. One, first of all, that is linear element, and it is time independent. It is time independent. That is the reason why we can't change that R from time domain to frequency domain or S domain. There will not be any change. That means the Laplace transform of R is simply R itself. Simply R itself. Okay? Is it clear? Is it clear? So this will be the Laplace equivalent circuit. Then what will be V0 of S? What will be V0 of S? It is nothing but VA of S. I told you the reason, why VA of t is directly VA of S? Because it's AC, it's time varying. If it is not varying, but a constant value, then only it will be Vi by S in the case of DC circuit and all. Clear? You have to clearly think of this R. Okay, you have to fix in your mind. But what is the reason why this R is again this R? First of all, linear, that will not depend upon the time. Whenever voltage is varying, correspondingly its current also varies, so that R will be constant all the time. It only depends upon temperature. That's not a function of time, right? That's why. So it will be VA of S into 1 by Cs whole divided by R plus 1 by Cs. Correct or wrong? Correct or wrong? Yes. Voltage division rule, simple voltage division. Input voltage into that impedance divided by R plus 1 by Cs. I already told you the reason. 1 by Cs means it is already in capacitive reactance form. No need to calculate for other or no need to multiply for frequency, and it is already multiplied. 1 by Cs means it's already multiplied. So what I am going to do, I am going to take 1 by Cs as common. So it will become VA of S into 1 by Cs whole divided by 1 by Cs into RCS plus 1. Correct or wrong? Correct or wrong? This 1 by Cs and 1 by Cs could cancel, or I can write like V of S divided by VA of S is equal to, what is that? 1 divided by 1 plus RCS. 1 divided by 1 plus RCS. Or this V of S by V of S is nothing but T of S equal to 1 divided by 1 plus RCS. That is nothing but the transfer function, where T of S is nothing but what? T of S is nothing but transfer function. Transfer function. T of S is nothing but Laplace transform, transfer function. Okay, where S is equal to J omega. Let's say S is equal to what? J omega. So by looking into the transfer function itself, we can say that whether it is a low pass or high pass. I will explain. Put S is equal to 0. Put S is equal to 0. What is that? T of 0 will be equal to what? 1 divided by 1 plus 0, which is simply 1. Put S is equal to infinity. What is that? T of S will be equal to, or T of infinity will be equal to 1 divided by 1 plus infinity, or simply 0. That means from the transfer function itself, it's clear that for low frequency or zero frequency, there is a transfer function, right? There is a transfer function. But for higher frequency or infinity frequency, there is no transfer function. There is no transfer function means transfer function, the other definition of transfer function is nothing but the Laplace transform of output by Laplace transform of input. Transfer function is equal to 0 means there is no output. 0 by something will be 0, right? So Laplace transform 0 or transfer function 0 means there is no output. That means from this also, from this it is clear that, from this analysis it is clear that it is a low pass filter. That means it passing low frequencies or zero frequency, or it block the higher frequency or infinity. So generally we can say. Or without knowing this Laplace equivalent circuit also you can predict by simply using this diagram. Let's see that. Put f is equal to 0 in figure 1. Let be figure 1 and let be figure 2. Put f is equal to 0 in figure 1. What will be the answer? What will be the answer? See. V of t, this is R. If f is equal to 0 means what will be XC, capacitive reactance? F is equal to 0 means XC will be 1 by c omega, which is nothing but 1 by 2 pi into 0, or it will be infinity, or it will be simply infinity. It will be simply infinity. That means this will be open circuited. So the output will be simply V0 of t. The output will be simply what? V0 of t. That means for lower frequency or zero frequency, the input is available across as simply as output. That means the output will be equal to what? At this time it is nothing but beta, it is simply input. The output is simply input. That means it passes the input to the output. That means it's a low pass filter. Or simply put f is equal to 0 or put f is equal to infinity in figure 1. Put f is equal to infinity in figure 1. What I get? See in figure, it is simply V of t, or if f is equal to infinity means x is equal to what? If f is equal to infinity means 1 by infinity, it will become 0, or xc becomes 0, or I can say that this will be short circuited, or this will be the output. This will be the output, or this we can say that here V0 of t will be equal to 0 volt. V0 of t is equal to 0 volt. Or from these figures we can say that for f is equal to 0 it passes the input signal. For f is equal to input, there is no output signal. The output is 0, which means there is no output, which means it blocked the input. That is why there is no output, right? It blocked the input, that is why there is no output. So that is the meaning. That is the meaning. So you don't need to by heart all this. This figure you don't need to memorize. In the question paper, if they are given and if they asked whether that is a low pass filter or high pass filter, simply you put f is equal to 0 first, f is equal to infinity other words. You will definitely get the answer. You will definitely get it. You don't need to actually calculate for this transfer function also. But simply I did this because you know both cases you have to understand. Regarding the transfer function or regarding simply the time domain function, both you have to understand. That is why I did for both. Okay, so that's all about the low pass filter. And next we have to see second order high pass filter. I think it's very clear to you. So later on we simply deal with time domain only, okay? Because in questions, the chances of question from this session is simply you give a figure, you are given a figure and you have to find whether it is a low pass filter, high pass filter, band pass filter, band reject filter, band stop filter, etc. That is the only thing you have to do. So next you have to see first order high pass filter. High pass filter, first order high pass filter. So this is the circuit diagram of a first order high pass filter. First order high pass filter. See, you can directly check whether it is high pass or not. We can check simply. Put f is equal to 0. Put f is equal to 0. What is that? What will be the diagram? Put f is equal to 0, what will be the diagram? Let's see that. VAFT simply like that. X equal to 0, f is equal to 0 means x is equal to what beta? X is equal to infinity, right? So this will be open circuit. And that R will be there. There is no change in R. And this will be V0 of t. So from this, V0 of t is nothing but 0. V0 of t is nothing but 0 because it's open circuited in between. So there is no output. So that we can conclude that what, or put f is equal to infinity. What will be the diagram? It will be short circuit, right? Or we can say that simply VAFT, right? V0 of t is simply VAFT. That means the given figure or the given diagram is of, for low frequencies it blocked, right? There is no output. That is the meaning of blocked. And for high frequency or infinite frequency, it simply allows the signal as it is, right? As it is. That is means it is a high pass filter. It allows only the high frequency. It allows only the high frequency. That's why the name high pass filter. That's why the name high pass filter. Okay. And I used the term here first order. First order. What is the meaning of that? I will explain. In the first order low pass filter, you got the transfer function as T of s equal to 1 divided by 1 plus RCS, correct? So order of this is, order is nothing but S, I mean 1. The order is nothing but the power of S in this equation. The power of S in this equation is called the order. The power of S in the equation is called the order. Or in derivative, you did some differential equation in mathematics, right? The order is nothing but the highest power of the derivative. But d square y by dx square means the order is 2. Correct? Order means something related to derivative. In similar manner, here also order is something related to what? S power. If in denominator, suppose it is like, suppose the transfer function is like this, 1 divided by s into s plus 2. What will be the order? The order will be simply what? Order will be simply 2. Order will be simply 2. The power of highest power of S is called the order. Highest power of S is called the order. So why the name first order high pass or first order low pass means order is equal to 1. What is the physical meaning of order? What is the physical meaning of order? I said that order is nothing but the presence of S, right? The presence of S is the order. When there is a presence of S happens, if there is inductor or capacitor, that means if there is a dynamic element in the circuit, then only that S term will be included. That S term will be included. Or the physical meaning of order is nothing but it is the number of dynamic elements present in the circuit. See, in the first figure, there was only one R and one C. That means the dynamic element is only C. That is why it is first order. In the second figure also see the dynamic element, the number of dynamic elements. Dynamic elements means something which changes with the time. It is only inductor and capacitor. Or some other are there, we will discuss later. So now, as far as now, it is inductor and capacitor. That are dynamic element, right? So there is in the figure, see here also one capacitor is there. That is why the order is equal to 1. That is why the order is equal to 1. Okay. So that is the meaning of order. So we are now going to discuss second order low pass filter. What is that? Second order low pass filter. So this is a circuit diagram of second order low pass filter. Second order low pass filter. How can we derive the equation? See, put f is equal to 0. Put f is equal to 0. What will be the equation? I mean, what will be the figure? It will be simply v of t. If f is equal to 0 means, what will be this XL value? It will be 0. It's simply short circuited. And here also short circuited. And here, if f is equal to 0 means x is equal to infinity, that means this session is open circuited. And the output is simply like this. Or we can say that V0 of t equal to Vft. That means for low frequency it allows the signal, right? And what is for f is equal to infinity? What is for f is equal to infinity? At f is equal to infinity, what will be the figure? This will be open circuited, this will be open circuited, and this will be short circuited. And V0 of t is nothing but 0. V0 of t, because it's open circuited from initially, no, so there will not be any output. So from this diagram, by looking the diagram, by applying some frequency range f is equal to 0 and f is equal to infinity, we got a conclusion that it allows the signal to low frequencies, but it blocked the signals at high frequencies. That means there is no output in the high frequency, right? That means the signal, I mean the system is, or the second order, this is the second order low pass filter. It allows the low frequency. And the name second order means there are two dynamic elements. One is inductor and another is capacitor. The splitting is, you don't know that splitting. Okay, the splitting is, you don't look up that, because it's simply L by 2 plus L by 2, simply effectively L and simply L. It will be a simple LC combination. Or how many LC combinations are there, that also you can check for that order concern. Okay, so the second order means there are two dynamic element, one is inductor and one is capacitor, because so that means we have to introduce S and S. Two S's you have to include, that means S square will be the result. That is why the order is nothing but 2. That means if you derive the transfer function for the second order, definitely the power of S will be 2. The power of S will be 2. Okay, we don't want to derive all this, because there is no control system. There we will derive all the things in different manner. Okay, so as far as now it is enough. So second order low pass filter. Next we have to see, this is actually this is 2 now, this is 3, and we have to see second order high pass filter. See, this is the circuit diagram of a second order high pass filter. Let's check whether it is high pass filter or not. Okay, second order means nothing but there are two dynamic elements, one is L and one is C. These are series now, 2C plus 2C. If capacitors are series, the effective will be in parallel like situation like resistor. 2C into 2C divided by 4C. It is nothing but, what is that? 2C into 2C divided by 4C is nothing but C. The effective will be C. So C into L, LC combination is 1. So there is one inductor and one capacitor effectively in the circuit. That is why the order is nothing but second order. That is why the order is nothing but second order. And let's check for that. F is equal to 0. But F is equal to 0 means V of t. 0 means it will be open circuit, right? And it will be short circuit, right? It will be also open circuit. So this will be V0 of t, or V0 of t is nothing but 0. And put F is equal to infinity, what will be? this will be short circuited, this will be open circuit, this will be short circuit. That means V0 of t will be V of t, because all the input will be available, right? So this is the case. So by looking into the figure, by analyzing with sample frequencies f is equal to 0 and f is equal to t, we concluded that it block low frequencies, it allow the high frequency. So it is a second order high pass filter. Second order high pass filter. Next we have to see band pass filter. Next you have to see band pass filter. So this is a circuit diagram of a band pass filter. This is a circuit diagram of a band pass filter. This is a circuit diagram of a band pass filter. Let's see whether it is band pass or not. Put f is equal to 0. It is very easy actually. You don't want to remember this circuit diagram at all. You simply put f is equal to 0 and f is equal to infinity gate. What answer you will get, that depends the nature of the filter. That's all. So f is equal to 0 means what will be the figure? Vft. F is equal to 0 means this will be 0 resistance, right? So this will be short and this will be open. This will be short and this will be open, and this will be short, this will be open. So this is the output. Is there any output? Because so many loop holes are there, right? So many opens are there, so there will not be any output. That means V0 of t will be simply 0 volt. V0 of t will be simply 0 volt. V0 of t will be simply what? 0 volt. There will not be any output, better. There will not be any output. There will not be any output. Okay? So that is, and let's check for f is equal to infinity also. No issue there. Let's check for f is equal to infinity also. Right? F is equal to infinity means this will be infinity resistance, so this will be open circuited and capacitor will be short circuited. Here also inductor will be open circuited, capacitor will be short circuited, and here also inductor will be what? Open circuit and capacitor will be short circuit. So this will be the answer. This will be the answer. So we can say that V0 of t is again nothing but, what is that? 0 volt. So we concluded here that it block the low frequency, it block the high frequency, it block the low frequency, it block the high frequency. That means it only passes a mid-range of frequency. It only passes some mid-range of frequency. So it is a band pass filter bus. Okay? Is it clear? Is it clear? Is it clear, my dears? And next you have to see band stop filter. Next you have to see band stop filter. What will be the diagram? So band stop filter. Band stop filter. Okay, band stop filter. Here you can see 1, 2, 3, 3 LC combinations, right? 3 LC combinations. So definitely it will be a third order filter. If you do the transient analysis for this, definitely the transfer function contain S cube like parameter, right? So okay, that's not our concern, but I thought okay. So what is the meaning of this band stop filter? So it will be f is equal to 0, but when you put f is equal to 0 means what is that? It will be, this will be f is equal to 0 means one will be open, other will be closed, right? One will be short, open, sorry, short. This inductor will be short now, and capacitor will be open. Okay. So what will be the output again? What will be the output again? See, so the input is here, it come here, it come here, and come here, it come here, it come here, it come here. That means V0 of t is nothing but beta VA of t. V0 of nothing but VA of t. Okay, VA of t. And another situation, f is equal to infinity. At f is equal to infinity, what will be the figure? This will be short and this will be open. This will be short and this will be open, and this will be again open and this will be short. V0 of t is nothing but that means for low frequency it allowed the signal, for high frequency it allowed the signal. So it will definitely stop some range of frequency which is nothing but mid band frequency. Some range of frequency it will definitely stop. That is the name band stop filter. That is why the name band stop filter. Is it clear? Is it clear? Band pass and band stop filter. Next, very important is all pass filter. All pass filter. All pass filter. Draw this figure. Draw this figure. This is all pass filter. This is all pass filter. I will tell you why this name all pass means it will allow all the frequencies, right? It will allow all the frequencies. We have to prove that, right? We have to prove that. Okay. Convert it into Laplace. Okay, it's very easy then, that's why. Convert it into Laplace. Convert it into Laplace. So it will become A of S. R is not changed, there is change in R. There is no change in R1 auto, but this will be conveyed by CS, right? And this will be V1 of S V2 of s, V1 of s and V2 of s. Output is nothing but V1 of s minus V2 of s. Here also output is nothing but V1 of t minus V2 of t. V1 of t minus V2 of t will be the output. That means if you take the two terminal as its output terminal, then definitely V1 of t minus V2 of t will be the output value. So in terms of Laplace, it will be like this, R1, R. And let's find what will be V1 of s and V2 of s. Okay, let's find what will be V1 of s and V2 of s. Okay, let's find that first. Let's find that. So what will be V1 of s? V1 of s is nothing but VA of s into 1 by Cs whole divided by 1 by Cs plus R1, correct? Simply applied voltage division rule. This is girthed. So VA of s into 1 by, because V1 of s means up to from here, right? V1 of s. V1 of s is nothing but this point with respect to ground, right? Ground is here. So up to this will be the V1 of s. So that V1 of s is nothing but VA of s into that impedance divided by total impedance, right? Total impedance means R1 plus 1 by Cs. If you take 1 by Cs outside, it will become divided by 1 plus R1 Cs, correct? Already derived, right? 1 plus R Cs, right? And what will be V2 of s now? What will be V2 of s? It is nothing but VA of s into, what will be V2? V2 is nothing but with respect to this and ground, right? This is also ground. With respect to this and ground is nothing but the V2 of s. V2 of s. Okay, so that will be V of s into R divided by R plus R, right? V of s divided by 2. Because 2R, R and R get cancelled, it is simply VA of s by 2. So our output will become V0 of s is nothing but, what is that? V1 of s minus V2 of s, right? V1 of s minus V2 of s, right? So it will be VA of s divided by 1 plus R1 Cs minus VA of s by 2. Correct? Is it correct? Is it correct? So it will become see, this is actually an analytical session, that's why you may feel slightly boring. Okay, it's an analytical session, right? That's why. So what will be V0 of s by VA of s? What is that? It will be 1 by 1 plus R1 Cs minus 1 by 2, correct? Minus 1 by 2. VA of s you can take in common and take 2 as denominator. So V0 of s will be V1 of s equal to 6. And this is nothing but 2 minus 1 minus R1 Cs whole divided by 2 into 1 plus R1 Cs, right? 1 plus R1 Cs. Or it's simply 2 minus 1, 1. 1 minus R1 Cs whole divided by 2 into 1 plus R1 Cs. 1 plus R1 Cs. Okay. So that is V0 of s by B of s, which is nothing but transfer function T of s. It is my transfer function T of s. 1 minus R1 Cs divided by 2 into 1 plus R1 Cs. Okay. And what will be the magnitude of the transfer function? My dears, what will be the magnitude of the transfer function? That is mod, before I put s is equal to j omega, okay? Put s is equal to j omega, then it will be easy, that's why. Put s is equal to j omega, because s value is nothing but j omega. So T of j omega will be equal to 1 minus R1c j omega divided by 2 into 1 plus R1c j omega. Okay. Okay. Then what will be magnitude of this function, transfer function? How can we write the magnitude of that transfer function? Magnitude of numerator by magnitude of denominator. Magnitude of numerator is nothing but 1 plus R1c the whole square, correct? One more time is omega also. Suppose in the form a plus jb, what will be the magnitude? A square plus the j term, the coefficient of j, so it will be root of a square plus b square, right? So that is why 1 plus a square plus b square. B is nothing but r1c into omega. The coefficient of j is nothing but r1c into omega. That's why r1c omega the whole square. Whole divided by this 2 is same as like this, and it will also 1 plus r1c omega square. This will be cancelled, right? So it will be simply 1 by 2. Very, very important. So magnitude of t of j omega is nothing but 1 by 2. What will be the angle of t of j omega? What will be the angle t of j omega? Angle means numerator angle minus denominator angle. If this is in the form of a minus jb, then what will be the angle? Minus tan inverse r1c omega by 1, right? 1 minus denominator, but 1 by 2 no? As far as angle concerned, we don't need to consider that 1 by 2, right? So minus tan inverse, again in denominator it will be again r1c omega by 1. That means minus 2 tan inverse r1c omega. That will be the angle of t of j omega. And this is the magnitude. This is the magnitude. Is it clear? And magnitude of t of j omega is nothing but 1 by 2. What do you infer from this? What do you infer from this? Or what do you conclude from this? An all pass filter having a constant magnitude means 1 by 2. That means its transfer function is constant. What is the meaning of that? The transfer function is constant means there is no factor which is associated with transfer function, so that it behave like a constant manner for all the frequencies, because there is no terms regarding omega in transfer function amplitude. Amplitude determines the output, right? Amplitude determines output. If something is here regarding with respect to, suppose it is omega by 2 or 1 by 2 omega or something like that, or some terms connecting omega, then we can say that it is not a all pass filter. It having the frequency dependent term in what? Omega, right? Suppose this is omega by 2. Imagine, suppose this is omega by 2. Suppose magnitude of t of j omega is omega by 2. Suppose omega is equal to 0 means the output will be 0. Omega is equal to infinity means output will be infinity. That means there will not be output for 0 frequency. There is output for what? Infinity frequency, right? Correct? That means it is frequency depending. It will allow certain frequency only. It will block some other frequency. That means it will not be an all pass filter. It will not be an all pass filter. But now, since the constant, that is the magnitude is constant, it is not depend upon any other parameters like omega, we can say that that is a what? All pass filter. But the angle term contain omega. The angle term contain omega. So we can say that this, since the angle term contain omega, this is not a constant phase angle producing filter, but a filter which allow all the frequencies, but with respect to some frequency, some phase angle will be there, or some phase lag or lead will be there depending upon the value of omega. And let's check in what range that angle will lie. Let's check that. Can I rub this? In what range that angle lies? Let's check that. Okay. Let's check that also. We have the angle equation as what? T of j omega is nothing but minus 2 tan inverse R1c omega, correct? Minus 2 tan inverse R1c omega. Put put omega is equal to 0. What will be the angle? Angle of T of j omega will be equal to angle of T of j omega, simply T of 0, right? T of angle of T of 0, angle of T of j omega will be equal to minus 2 tan inverse 0. What is tan inverse 0? It is simply 0, right? So 0. And put omega equal to infinity. What is that? Angle of T of j omega will be equal to, what is that? Minus 2 tan inverse R1 into C into infinity. That means minus 2 tan inverse infinity. What is tan inverse infinity? It is 90. It is 90, right? Sin 90 by cos 90. 1 by 0 it will become infinity. So we can say that minus 2 into 90 or minus 180 degree. Or we can say that the angle ranges from 0 to minus 180 degree. The angle of is very important question. You may expect a one word question from this concept. What is the phase angle range of all pass filter? 0 to minus 180 is very, very important. 0 to minus 180 degree. Is it clear? Is it clear? So that is the concept of all pass filter. No, it is very important. All pass filter is very, very important. So you have to remember the circuit diagram of all pass filter. Remaining all the diagram you don't need to remember, because if you directly put f is equal to 0 and f is equal to infinity itself, you will get the answer. Why we have to waste your memory? You don't need to remember those figures, but you have to remember this all pass filter figure, right? All pass filter RR R1C. Okay, yes. So that's all about the all pass filters. And one more thing I have to tell you, it's very important while doing calculation. Suppose if some complex number is in the form of x plus jy, then its angle will be what? Its angle will be what? Its angle will be tan inverse, what is that? Y by x. Correct. Tan inverse y by x. If it is something in the form of x minus jy, if angle will be tan inverse minus y by x, or simply what? Minus tan inverse y by x. Minus tan inverse y by x. If it is in the range of minus x plus jy form, it will be 180 minus tan inverse y by x. If it minus x minus jy format, it will be 180 plus tan inverse y by x. Very, very, very important. You have to remember all this because it's very, very, very important. Very, very, very important. Because while applying some angle, how can we find the angle of different types of complex numbers or complex equation? No, you have to use this equation and you will definitely get a correct value of angles. Otherwise, no, there may be some confusion, so that there is a chance of error. There is a chance of error. Okay, so this you have to remember all the time. This you have to remember all the time. X plus a by tan inverse y by minus 180 minus and 180 plus. Okay, so what is the time now? Okay, beta, that's all for today's session. So let's meet tomorrow with a new session. Okay, coupled circuit. That is a very interesting session. No, I know this filter section is somewhat boring. I know that because it's analysis. No, that's why. But next we will do coupled circuit. That's very interesting. Problem solves very, very interesting. So in filter section there is hardly see some problems like I will explain that also when doing problems. I will explain that also. But problems are very rare in this regarding these filters. We have to just keep in your mind that what type of filter. In question paper you may have some diagram and what filter it is. This is a way in which the question will be asked. Some diagram will be there, what the filter is. Options: band pass, band rejects, stop, low pass, high pass, etc. You have to tick one. So simply put f is equal to 0 and f is equal to infinity, you will get the answer bus. And you have to take care of this all pass filter, its frequency range, its angle range, and why it is called the all pass filter. No, that proof also. That's for your understanding. magnitude is equal to 1 by 2. For that's for your understanding. How it is all passed? No, definitely there is a question. No, for that is the answer. Okay, so that's all for today. Let's meet again tomorrow. Bye.